Okay, so now we've going to start 9.3 and 9.4, where we're going to do some proofs. And here the first thing we're going to list is the steps you need to go through to take care of your proofs. So the first thing you're going to do is label your picture. And I'm writing with my fingers, so it's not going to be the prettiest. The first statement is always going to be your given. Okay. And that's given in the problem, that's any information, and your reason is going to be the word given. Now we did 2-column proofs earlier with algebraic proofs, so you may remember this. We're going to go from there and deduce any information we can deduce from that particular given until we reach a congruency, and I'll go through some examples so you can see what we mean. Okay, so we get a congruency, and then you go to the next given and do the same thing, and you want to get 3 congruencies. Now if you don't get 3 from your givens, then you go back and look for a reflexive side, a reflexive angle, vertical angles, anything that we can deduce without other information, and so to get that third congruency. And once you do that, you're going to have your proof, and it's going to be, the reason is going to be side, 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 angle, side, or angle, side, angle. And then the last statement is going to be our proof statement, that we've succeeded and we've proved that the 2 triangles are congruent. Now the reason is not the word prove. Never put the word prove as a reason. The reason's going to be SSS, SAS, or ASA. One of those is going to be your proof statement. So now let's go on to example 1 on the next page. Okay. We can see that our first given is that AD is congruent to AB, and I'm going to mark that on the triangle, and I'm going to write down here AD is congruent to AB, and the reason is that it's given. Okay, now that's one congruency that's done, and it's done with the given. I don't have to deduce anything else. That's our first congruency. So if you want to mark out on the side a C so you can see that you've got one of the 3 done, then that's great. Then our next one is also a given. We've got DC is congruent to BC, and that's also given. Okay, so DC and BC are congruent. Again, that's already a congruency statement, so I'm done. But I only have 2. I need a third one, so there's only 2 givens. So now what did we say? We said look for a reflexive side or reflexive angle. Well, we see that this side here, CA or AC, is shared between both triangles. It's a side of each of the triangles. So from that you say that AC is congruent to AC, or you could say CA, either way. And that property that you're going to use for that was that anything equals itself is the reflexive property. And so that proves our third congruency. And now our proof statement, we go to the prove up there where it says prove, and we write that just like it is. Triangle ADC is congruent to triangle ABC. We have successfully proved that. And our reason is side, side, side. We proved that 3 sides were congruent. Okay, so now we're going to go on to the next one. Proof number 2. And so from that one, it says our given is that AC bisects DAB. So we write that just like it is. That line AC, okay, bisects angle DAB. And that's a given. And now let's go to our figure and mark that. So what that means is that this angle and this angle are the same. So you can put a little curve with a slash marker. You can just put one curve, because that would indicate that they're the same measure. Now, that doesn't prove congruency, But because of the definition of a bisector that says that angle BAC is congruent to angle DAC, because that's what a bisector means, that it cuts one angle into two congruent angles. So there's a congruency statement. And our reason is that that's the definition of an angle bisector. Okay, definition of an angle bisector. Then our next congruency statement, or our next given, is that angle 1 is congruent to angle 2, which is already a congruency statement, so we don't have to worry about drawing any conclusions. That's a given. Okay, and so we're going to mark that on the picture. Angle 1 and angle 2, we're going to mark them with two curved lines to show that they're congruent. But that's only two congruency statements, so we need a third one. Well, again, we're going to look here as a reflexive side, a shared side. So we're going to go, and we have another congruency because we can say that AC is congruent to AC, which is reflexive. Okay. And then our proof statement, triangle ABC is congruent to triangle ADC. And in this case, it's angle, side, angle. Okay. Now to our third proof on this 9-3. We've got C given. C is the midpoint of line or side BD, and that's given. That doesn't prove congruency, but by the fact that it's a midpoint, it's going to prove that BC and DC have the same measure. So there's our congruency statement, our first congruency statement. BC is congruent to DC, and that is by the definition of a midpoint. That's what it means to be a midpoint. Then our second given is that C is the midpoint of AE. Okay, that's also given. Okay, so that means that AC is congruent to EC. And again, that's also by the definition of a midpoint. So that means that if I'm marking it on my figure, these two lines are congruent. Now, what's our third congruency? We don't have a shared side, we don't have a shared angle, but we do have a pair of vertical angles. So angle BCA is congruent to angle DCE because vertical angles are congruent, and they're vertical angles. Okay, so that means that these two angles have the same measure. So now we have three congruencies. So we can say that triangle ABC is congruent to triangle EDC, and that one is side, angle, side. Now our fourth example on 9-3. First given that HY is congruent to LY, so that's already a congruency statement. Okay, and that's given. Okay. Then we have that WH is parallel to LF. Okay, now that's not a congruency statement, but we can mark it on here with arrows that those two lines are parallel. And then we use parallel lines cut by a transversal, what we know about that, to say that angle H is congruent to angle L. There's a congruency statement. Because with parallel lines, this is given. Okay. So if the lines are parallel, alternate interior angles are congruent. Okay. Then we still need a third congruency statement. So let's mark the ones we just said. That was H and L there and here. Then we have this set of vertical angles in the middle. So we can say that angle HYW is congruent to angle LYF because vertical angles are congruent. And so now we have our proof statement. Triangle WHY is congruent to triangle FLY, and that one is angle side angle. Okay. Now on 9.4 you have another list of steps. I'm going to skip those and go straight to the set of proofs. These proofs may be a little harder, a little different picture, so let's go through and run through those. B is the midpoint of AC, and that's given. Okay. So if B is the midpoint of AC, that's going to mean that AB and BC are congruent. So there's our first congruency statement. AB is congruent to BC, and that's the definition of a midpoint. Okay. Then we have another given. BD is congruent to AE. There's a second congruency statement, and that's part of the problem. It's given to us. So these two are congruent. Okay. Okay. So then we have another statement that's given. We have that BD is parallel to AE, and that's another given. Okay, so we could draw in some arrows here if we wanted to show that those are parallel lines. And because of that, we know that angle 1 and angle 2 are congruent, is congruent to angle 2, because I hope you remember what kind of the angles those are. Those are when these lines are parallel, those are corresponding angles. So if you have parallel lines, then, oh, sorry, I keep drawing lines. Corresponding angles, I'm running out of space, are congruent. Okay, So when you have parallel lines, corresponding angles are congruent. And then we have our proof statement. Triangle ABE is congruent to triangle BCD, and that's going to be side, angle, side. Okay, so there's a little different thing, something else you can look for. Let's go to our last two examples, and I'll try to get this uploaded to YouTube. So example 2, we've got that BA, side BA is perpendicular to YZ. So what that means is that this is a right angle and this is a right angle because those lines are perpendicular. So that means that angle 1 and angle 2 are right angles. And our reason here, the first one is that it's given. Second is the definition of perpendicular. Okay, but then we can get a congruency statement. Angle 1 is congruent to angle 2. Okay, because all right angles are congruent. They're all equal to 90 degrees. So there's one congruency. Then we have that BA bisects angle YBZ, and that's a given. Okay, so that's going to lead us to these angles being congruent. Angle 3 is congruent to angle 4, and hopefully you know by now that's the definition of an angle bisector. Okay. And then we have a reflexive side, so we have AB is congruent to AB, and that property is reflexive. And now we have three congruencies, so we can say that triangle AYB is congruent to triangle AZB, and that's angle, side, angle. All right, last proof. Okay, BA, side BA is congruent to side ED, so there's a congruency statement, and that's a given. So BA is congruent to ED, and then BA is parallel to ED, and that's another given. So we can draw our little arrows to show that those are parallel. So from there we can say that angle A is congruent to angle D, because we've got parallel lines, which means alternate interior angles are congruent. Okay, so there's another congruency statement. And then we have another given. C is the midpoint of AD. Okay, and that's a given. So that leads us to another congruency statement. If C is the midpoint. That means AC and AD, or CD, are equal lengths. So now we have C. AC is congruent to DC, and that's the definition of a midpoint. And that was we were led to that by the givens. We also could have said that BCA and DCE were vertical angles, which would have given us an angle-side angle. But based on our givens, we see that triangle BAC is congruent to triangle EDC, and in that case it would be side, angle, side. So I would take the other one as correct, but based on our givens, this really leads us to this type of proof. So that's 9.3 and 9.4. Work on homework 9.3 and 9.4, and I'll hopefully be back in class tomorrow.